For this problem, we are given a bunch of information about a function y equals f of x. And from this information, we're asked to sketch the graph of it. I'm actually going to add to that ideally in order to sketch it, we need to figure out where our critical points are, if any of them are local max or min, and figure out our intervals of concavity and inflection points. We have all the information that they gave us. One key point that as part of the information is that the function is always defined and it's always continuous. So there's no breaks in the graph. And so even though all of the information is given to us all at once, I'm going to go through this process in order to create a sketch in a similar order to the way we did these homework assignments. And that first I might try and pick out any critical points. And so for the critical points, because they're saying the function is always defined and continuous and everything, it looks like the only critical points are at y prime equals 0, or are when y prime equals 0. So this would be at x1 and x3. And then from there, I'm going to look at, and I might even redraw, because this is so messy, the number line to help organize my work. And it tells me that y prime is greater than 0 here. And so I'm not going to rewrite this, but this means what? Y prime is greater than 0. The derivative is positive, so that means f is increasing. And here, y prime is greater than 0, f is still increasing. And y prime less than 0, we see that f is decreasing. And this helps me with the first derivative test to see that I have a local max there, and that this is a critical point that is not a local extrema. And that can help with our sketch as we go on. And so here, I'll just write that down. We have a local max at x3. Okay. And then the next thing, we have increasing and decreasing information. The next thing is, what information does the second derivative give us? And from here, I'm going to redraw the number line. It looks like special spots for the second derivative were at x1 and x2. And before x1, the second derivative was negative. So that tells me we're concave down. And then after x1, y double prime or f double prime is positive. So that tells me we're concave up. So this critical point, x1, looks like is going to end up being an inflection point. And then after x2, y double prime is negative, so concave down. And so it looks like we have two inflection points. At x1 and at x2. And so pulling all of this information together, I have an x1 where we're concave down. We're always increasing before and after. And we're concave down, and then we're concave up. So that tells me I have a picture that's similar to x cubed at the origin. This would be at x1. And then we're concave up, and we're still going uphill until we get to x2. And then we change to concave down. Kind of hard to see exactly where that might change. And then up at x3, we're concave down all the way after x2, and at x3 we have a local max. And so that is one sketch from all of this information. Doesn't have to be exactly that. And notice I don't have any tick marks because we don't know what these actual values are, but we don't know how high. We don't know the y values, but we have a sketch that of what the graph may look like.